Now let's take a look at solving inequalities. When you're solving an inequality, it's a lot like an equation. Basically, all the same rules apply. There's just a couple of little exceptions, a couple of little things that we do which make, in essence, it'll make graphing easier in the future, which is the next lesson. But it also helps out with coming up with the right answer. So the couple things that you got to watch out for extra on top of just solving it like it's an equation is you want the variable to be on the left. If the variable's not on the left, conceptually it's a lot harder to look at. The other thing that you need to be aware of is that if you multiply or divide by a negative, you must flip the symbol. And I'll get into the reasons why for that in a moment. But as far as a rule goes, if it's greater than, it turns into less than. If it's less than or equal to, it turns into greater than or equal to. So don't let it get to you if you're flipping it. We'll explain why in a minute. So I left the first one pretty straightforward. The first example is 3x is greater than 12. Now when you take a look at 3x, it's 3 times the x. Divide both sides by 3. I'm just treating this like it's an equation. X greater than 4. Now notice I divided by a positive number. No need to flip the symbol. And lo and behold, the variable is on the left just like we like it. So x is greater than 4. Look at the next problem to the right. It's negative 3x is greater than 12. I'm going to divide both sides by negative 3. X, 12 divided by negative 3 is negative 4. Do I flip the symbol here? Yes, I do. I don't flip it because my answer is negative. A lot of times some students think if the answer is negative, you flip it. No. I'm dividing it because of the number I divide. I'm flipping it because of the number I divided by. I divided by negative 3, so I need to flip that symbol to less than. So that's x is less than negative 4. All right. 6x minus 17 is less than negative 5. So this has got 2 steps. This is a regular 2-stepper. I got to get rid of the minus 17. So I'm going to add 17 to both sides. So I get 6x less than negative 5 plus 17, that's positive 12. I'm going to divide by 6, divide by 6. X is less than 2. All right, so I'm just doing the same thing here, just like an equation. I've been lucky so far. The variable has just been landing on the left. If it's not landing on the left, you need to make sure it gets over there. And if you happen to divide by a negative, you flip the symbol. I haven't forgotten. I will explain why in a moment. Let's do this one. Again, another 2-stepper. I'm going to go plus 4, plus 4. And so I've got negative 5x is greater than or equal to negative 25. Negative 5x greater than or equal to negative 25. I'm going to divide both sides by negative 5. And I get x less than or equal to, because I divided by a negative divided by a negative is a positive, and that's a positive 5. All right. Keep in mind, let's explain that now. Let's work with the first one. This is telling me the answers that are true have to be smaller than or equal to 5. Well, I'm going to pick a number smaller than 5. I'm going to pick 0. Now, I like 0 because it makes the calculating a lot easier. If I put 0 into this, I would get negative 5 times 0 minus 4 is greater than or equal to negative 29. Anything times 0 cancels out. And I'm looking at, is negative 4 greater than or equal to negative 29? Is that true? And the answer is yes. Negative 4 is larger than negative 29. All right? You'd rather owe $4 than 29. The negative 29 is smaller. If we don't flip the symbol, if I would have left the symbol as a greater than, I would have had to choose something like 6 or 7 or 10. Choose any number larger. And let's say I had chosen 10. Negative 5 times 10 minus 4 equals negative 29. Well, that would give me negative 50 minus 4 is greater than or equal to negative 29. Is negative 54 greater than or equal to negative 29? And the answer is no. You see, flipping the symbol is an adjustment that we make. Now, I know there's some people with PhDs in mathematics that are just groaning and screaming at the screen right now and saying, that's not the reason. That's an explanation of what we're doing. We're making an adjustment. There is a formal proof, and if you were to get up into a much higher level math class, we could run through that formal proof. But basically, we can see here that, hey, if you flip the symbol, it gives us a set of answers that works. If you don't flip the symbol, the answers won't work. All right, the last one I'm going to do for you, 2x and negative 5x. Now, there are some people that say, okay, take 2x away from both sides. If you do that, you're going to be leaving the variable on the right. Where do we want the variable to be? On the left. So I'm going to have to add 5x to both sides. I know there were some people that were tempted to divide by negative 5 there, but if you divide by negative 5, you're still going to leave the x. You've got to eliminate it completely with addition and subtraction. Gives me 7x minus 12 is less than or equal to 23 plus 12 to both sides. Getting low on the board here. 7x less than or equal to 35. Divide both sides by 7. Can't get any lower now, so I'm just going to write to the left here. X is less than or equal to 5. So there you have it. Treat them just like equations. Get the variable on the left, and if you happen to multiply or divide by a negative, make sure you flip the symbol. Good luck.